Hi and welcome to this video in the Get Started series. We're going to be looking at Get Started 3, which of course follows on from Get Started 2. You'll find the files used in this video in the folder int04. Alright, in this video we're going to be looking at more complex variable definitions. We've done some simple definitions in the first two videos. We're now going to look at some of the other constructions that you're allowed. And we're going to do that by looking at some conditions that are probably very unlikely, but at least cover all of the different operators that you are usually going to be using. So for that purpose, I've got a variable here called myvar, and it's a multi, and it's the name of it, myvar. It should be said that the case of the variable name is totally ignored in MRDCL. Whether you use uppercase or lowercase or a mix of upper lowercase will not affect its use. They're interchangeable, and so effectively everything is treated the same, whether it's upper or lowercase. So let's look at what we've got here in this variable, and you'll see the first bit of this variable begins 11/1, .12/1 and 13/1. Now what this means is that in the 11th column we've got code 1. Dot means and, so it means we've got people who are 11 code 1 and 12 code 1 and 13 code 1. So to go into that bit of the variable, they've got to fulfill all of those conditions. If they only fulfill one or two of those, they won't get into that bit of the variable. So if we quickly look at our data, you'll see here the first record has those three codes, so it would go into that bit of the variable, but the two below it certainly wouldn't. Alright, let's go back and look at the next bit in the variable. The next bit is 4 plus 5. Now it's sometimes confusing and takes time to get used to, but dot means and plus means or. So what I'm picking up here is 4 plus 5, which means 4 or 5. So any respondent that has 4 or 5 will get picked up. Now you'll see before this it hasn't got a column number before it. So what MRDCL does, it assumes you're referring to the last column number or variable that you had picked up. So this will mean, as there's nothing before this, that we're still working on column 13. You could repeat that, there'd be no problem with that. Repeating it is absolutely fine, or you could obviously change it to a different column, but by putting nothing, it's just going to assume that we're talking about column 13 still. And let's look at our data again and move to column 13. Which is that column, and we can see that record, the second record, has a 5, so that should get picked up by that definition of 4 and 5. On to the third bit in the variable, and we get 6.8. Now 6.8 literally means in the range of 6 to 8, so it will pick up 6 or 7, anybody who has 6 or 7 or 8. I could have typed that as 6 plus 7 plus 8 and it would have meant the same thing. But of course, if you're picking up a whole series of codes from 1 to 9 or something, it's obviously quicker to go 1.9 than typing 1 plus 2 plus 3 all the way up to 9. But 6.8 means just that, 6 or 7 or 8. The next thing we get in our list here is 1.n2. Now, what this means is they've got 1 and, dot means and, they haven't got 2. Now, when we've got ASCII data as we have in this example, nobody could have a 1 and a 2 in that particular column. So anybody who's got a 1 will effectively not have a 2. But that's just there for syntactical reasons to explain the 4 different types of definitions that you can have. You can obviously have these with variables, and we'll look at that in a minute. So you could pick up people who had 1 and not 2 a bit of a variable. On to the next one, we've now got a negative with a range, so that means not 3.5, so that means not in the range 3 to 5. Now that, the signs change here, so this, you wouldn't say that as not 3 plus not 4 plus not 5. You could also say that as not 3 and not 4 and not 5, because that's what it means. So not 3.5 means not 3 and not 4 and not 5. In other words, nothing in that range of 3 to 5. And if we look at column 13 again, that would apply to the first record, not the second record, but it would apply to the third record as well. Not 6 plus not 7 is something that I've hardly ever seen, but I put it in just to explain how wrong it is, or usually how wrong it is perhaps is more accurate. That means anybody who hasn't got 6 or they haven't got 7 in column 13, which I think will be everybody, because everybody will either not have 6 or they'll not have 7. So that's a slightly unusual one, and something that I can't ever remember when I've actually used that, but it's there just to explain its almost irrelevance. Now, the next thing we have is not referring to codes, but it's referring to the structure of that column effectively, or the way that column's coded. S means single, so that pick up anybody who's got a single answer in column 13. Doesn't matter what code it is, it could be any code, but they have just one answer in there. The next bit is picking up anybody who's got a multi in there. Now, because the data's ASCII, nobody will have a multi-code in there. But if you're picking up from a variable, that's quite possible they had a multi, had 2 answers in that particular variable. But it's in there for completeness. And blank will pick up anybody who's got nothing in that column. In other words, it's completely empty. There's nothing in there. Now we come to 2 definitions which are picking up true and false. Now, true and false, T means that everybody will go into that bit, and false means that nobody will go into that bit. Now, you might be curious why anybody would want people to go into every bit of a variable, or nobody to go into a bit of a variable. This is really probably for later, where you start to sometimes do tables where you want to control which people go into tables, and you don't want some people to go into others, and I have used that technique there. We'll come across this in future videos, but at the moment just accept that everybody will go into that bit of the variable and nobody will go in there. And finally in this line we've got $/1 to 2. Well, the /1.2 means anybody in the range as 2 as before. $/ means you're self-referencing the variable that you're currently in. So what this means is anybody who's in the first 2 bits of this variable. So they're either in here or they're in here. They could be in both, but as long as they're in one of those, they will go into that final category, $/1.2. So it's self-referencing. One thing about this, it is the last bit in this particular variable, so it would by definition have to refer to something before it. But in a longer variable, say we had another 5 bits on the end, it couldn't refer to something after this particular point in the variable. So if it was, let's say, 100 bits long, we couldn't say 41.42 because it's not in the first few bits of the variable that we've already defined. So that's quite useful. I tend to use that when you've got something very complex in the definition. So if we had a couple of really complex definitions in my first 2 bits, I wouldn't want to then have to type it all in again to explain it's either of those. I can just say, well, it's either of the 2 bits, first 2 bits in the variable in which I'm working. So we come down here, this is all familiar now. X is the labels and XT is the title, and they're just brief descriptions of what I explained to you. As before in the previous example files, most of what I've said here will be available in those comments below. Now we're going to move on to another variable, myvar2, and this uses brackets. And you're allowed to use up to 6 levels of brackets in MRDCL. I personally find once you get beyond 2 or 3, it gets very complex to understand what you're doing, and sometimes doing it in steps in different variables is a better way to go. But this shows how brackets work and what happens if you don't use brackets, more to the point. So what this is saying is we want people who fulfill 9 a 1 and 5 a 1 or 9 a 2. So they can be either of those things, but if they've got 9 a 1, they must have 5 a 1 to get into that particular bit in the variable. So that bracket there, you could argue, is redundant on the end because it's not bracketing anything away from this. But it's sometimes good practice to put things in brackets just to be clear what you're doing. If you don't have brackets, it might mean something completely different. If we take the brackets off just temporarily, the way MRDCL works is from left to right. So it would say, I want anybody who's 9 or 1 and 5 or 1, or they've got 9 or 2. So if they had those conditions, it would work from left to right with the ands and ors. So it's generally good practice to put brackets in if you're mixing and or. That's my general advice, because it's not really going to take much more time for MRDCL to process, and it becomes a lot clearer what you're doing. And you could put brackets around this expression here and obviously combine that with something else, and we'll see one of those a little bit more further along. So now we're looking at one that hasn't got brackets. So this is saying 6 or 1 or 5 or 1 and 9 or 2. So brackets haven't been used here, but the brackets will be implied as though they're here, because the 9 or 2 being the last is going to be the overriding definition. So if that's what you wanted, you wouldn't need to put brackets, and certainly some advanced users don't put brackets when you don't need to if they know exactly what they're doing. But it would work from left to right. If we reverse that expression and said $9.2 and 6 or 1 or 5 or 1, we could get very different answers out, because the or 5 or 1 would be the last definition, or the last governing factor, if you like, that controlled who went into that bit of the variable. And here's something you might want, where you want to bracket 2 halves. Again, ands and ors mixed together. So 5 or 1 and 9 or 1. So if you've got 5 or 1, you need 9 or 1 to go into this bit, or you need 5 or 2 and 9 or 2 to get into that bit of the brackets. It's worth just studying those and just getting familiar with how brackets work and the importance of how things go from left to right. And when we come to arithmetic in a later video, you'll find the same works with brackets there, that they work from left to right, unless you use brackets. Alright, so that's done that. Now we're going to just save that work, and we're going to run this and just have a look at our tables. So if we go back to our first variable, myvar, you can see we've got one person who was a 1 in 11, 12 and 13. There was one person who was in 4 and 5 on column 13. One here, one here. People didn't have codes 3 to 5, there was 2 of them. Everybody had that rather strange condition of not 6 and not 7. Everybody was single coded, nobody was multi-coded, nobody was blank. The true was always set on, the false was always set off, and either of the first 2 bits was the 2 people in these variables here. They could have been the same person, in which case we'd have got 1, but they were different people. And then when we look at myvar2, again we get some figures, which if you look at the files in data1.ask, you should be able to track that through and verify that that's correct. Alright, let's go back to the rest of the script for Get Started 3. We now move on to myvar3, and what myvar3 does is it picks up something from another variable. So you can use pretty much the same syntax we use to pick up from data locations and columns as you can from picking up from variables. So myvar3 is picking up the first answer in myvar1. So the first answer in myvar1, if we go back far enough, is that definition there. So we're just picking up that definition in myvar3. And then the second bit is people who gave answer 2 at myvar2. So that's picking up those people there that were fulfilling that condition. I think it was 2 people. And finally, in myvar3, we're picking up people who said myvar1 and myvar2 are 1. So again, using and, but picking it up directly from variables. Let's look at the results there. They're in table 3. Here we are. The first bit of myvar1 is 1. second bit of my_2 is 1, and people who had the first bit of my_1 and the bit 1 of my_2 is also 1. So we've got a table out there that does just what we want. Alright, let's go down to the next variable. Now this is a slightly curious variable, but something that's worth understanding, and it really highlights the difference between bits and perhaps responses on a questionnaire. So if we pick these up in a rather strange order of 7, 1, 8, 1 and 6, 1, which you may remember from previous videos meant went to see a film, sporting event and ate a restaurant, we picked them up in a slightly, if not illogical order, but in a different order to what you might expect. Now if we pick up var q2x and we pick up bit 1 of var q2x, that's going to be went to see a film. If we pick up bit 2 of variable q2, we need to go back up to the top and look at q2, and that will be the same thing, because in q2 we picked up the responses in the logical order, if you like, of 6, 7 and 8, which was also went to see a film. So what we've done here is we picked up the same data, but we picked it up from different variables, and in one variable it's bit 1, and in this variable it's in bit 2. So it's important to understand that bits and codes don't necessarily follow the same pattern. And say you had a question where there wasn't a code 1 and you picked up 2, 3, 4 and 5 as the codes, code 2 would end up as bit 1, code 3 as bit 2, up to code 5 being bit 4. So it's worth understanding how bits and, in variables needn't be the same as the codes that they are picked up from. And finally here we've got q2x1 and 2, which is people who went to see a film and a sporting event. And if we go down to that table, here it is. We've got 2 people who fulfilled the first condition, was went to see a film. That's the same answer, so it should be the same figure, but picked up from a different variable. And 1 person saw both a film and a sporting event. And again, you can work through that exercise on the with the data using the files that we supply. So that completes this video on picking up codes and bits from variables. There's 3 more in this series of Get Started, which you can follow in 4, 5 and 6. Thank you.